Okay, in this problem, we're given a graph of charge with respect to voltage for each of the capacitors, and then they're put into this circuit, and we're told that the battery is 6 volts. So when you look at the graphs and you understand the relationship Q is equal to V times C, then when we plot Q versus versus V, we can see that the slope of the line is going to be capacitance. So the kind of step number one is figuring out the capacitance of C1, C2, and C3. The scale here, that's 2, and that's 4, and this is 16. So that means that each one of these lines is 4. So when I look at line 1, I'm going to kind of focus my attention to that point right there. Since the y-intercept is 0, I can just say, all right, well, let's take that ordered pair. The change in y is going to be 24, and the change in x is going to be 4. So 24 over 4 is going to be my capacitance, which is going to give me 6 microfarads. Notice that the scale on my y-axis is microcoulombs, so therefore my capacitance is microfarads. I'm going to use the same method to identify that point and that point right there, and I get 16 over 4, or 4 microfarads, and then finally I get 8 over 4 for 2 microfarads for capacitor 3. I'm trying to figure out the charge stored on capacitor 2, and the charge stored on capacitor 2 is just going to be the voltage across capacitor 2 times its capacitance. Now I know the capacitance, but I don't know the voltage, so I'm going to need to kind of rethink this for a second. Now, I'm going to redraw the circuit because this is an important point in doing this. Here's C1, and what I'm going to do is, instead of drawing C2 and C3 in parallel, I'm going to draw them as just one equivalent capacitor. So I'm going to call that CEQ. So basically what I've done is I've taken the stuff in the green cloud and replaced it with a single capacitor. Now, I should recognize that this is the positive terminal of the battery, so this becomes plus Q, minus Q, plus Q, minus Q. The equivalent capacitor and C1, the series capacitor, have to have the same charge. They're in series with each other. So I can answer this question by saying, all right, well, before I even get started, I can figure out the equivalent capacitance in the entire circuit. CEQ. Well, C2 and C3 we're just going to add together. So that's going to be 6 microfarads. So we know what that is. That's 6 microfarads. And we also know that this is 6 microfarads. So they have the exact same capacitance. And so therefore they're going to have the exact same charge on them. And the voltage drop across the equivalent capacitor that I've drawn here in green and kind of shown here has to be the same. So it's all going to be equal to 18 microcoulombs. How did I get that? Well, I can say that the voltage across the entire circuit times the equivalent capacitance of the entire circuit is equal to the charge. Well, the voltage was given to us in the problem. It's 6 volts, and the equivalent capacitance of the entire circuit is going to be 3 microfarads. And so therefore, the charge is going to be equal to 18 microcoulombs. By the way, I got 3 microfarads by saying the equivalent capacitance that I'm interested in is 4 plus 2, or 6. So this would actually be 1 over CEQ is equal to 1 over 6 plus 1 over 6, which is equal to 2 over 6, or 1 over 3. And then solving for the equivalent capacitance, I get 3 microfarads. So that's kind of where that comes from. So I've got 18 microcoulombs of charge stored here, but also in the other places as well. Because the capacitors are identical to each other, I can then show that the voltage dropped across each is going to be the same. So I'm going to have the same voltage V here that I have dropped across the equivalent capacitor, which is going to be half of the battery voltage, or 3 volts. So now I'm ready. I can basically say I've identified the fact that there's a 3 volt drop here. I'm ready to use Q2 equals V2 times C2. And the voltage dropped is 3 volts, and the capacitance of number 2, capacitor 2, is known. It's 4 microfarads. And so now I'm ready to basically answer the question. 4 times 3 is 12 microcoulombs is my answer. And that is question number 16 in the Halliday, Resnick, and Walker book.